Hello everyone, this is a video lecture for Pre-Calculus Section 6.2 Trig. They're going to talk in particular about trig of right angles because later on we're going to have trig without right angles. Kind of weird because what we've been doing is trig with right angles. Whenever you're talking about unit circle, that's basically the same thing. This is going to be a lot of copy-paste of what we've already been seeing. So first off, let's draw a triangle. I'm going to try to draw that a little bit better. That'll work. And so I got theta. This is my adjacent side. This is my opposite side. This is my hypotenuse. But now, I'm going to tell you, let's just say that this was unit circle, because, well, it is. Let's just say that this is unit circle here. You get what I'm saying, right? This is basically my x, this is my y, and this is my r. And so we've already seen this. This is no different. This is unit circle, same thing as last time. Same as like in chapter 5, basically. So I got sine of theta. Notice they're using theta, not t now, thankfully to me. Y over r, or again, opposite over hypotenuse. My cosine of theta is equal to x over r, or adjacent over hypotenuse. And then finally, tangent of theta is equal to y over x, or opposite over adjacent. And if you remember unit circle in particular, when I said unit circle, I meant that r is equal to 1. Therefore, my r's just disappeared. You got sine equals y and cosine equals x. So that's cool and all. That could still pertain to what we're doing. It kind of depends on the problem, honestly. Most likely they'll give you an r, a hypotenuse now. One last thing, the Pythagorean theorem. If I spelled it right. You couldn't tell anyways. X squared plus y squared is equal to r squared. There you go. So, of course, can't just stop at those three. There's three more. We got cosecant, it's 1 over the sine. Secant is 1 over cosine. And cotangent is 1 over tangent. Okay, awesome. So we got it all now. Let's do some math problems. So they got this weird triangle like this. Of course, they're wanting to make it weird on purpose. This is my theta, which they are, actually they're not saying what theta is at all. This amount over here is 24. This side is 45. And they say, go, figure it out. They want sine, cosine, and tangent and all that kind of stuff of theta. I need the hypotenuse right now. And so what I'm going to do is the Pythagorean theorem, 24 squared plus 45 squared. And you square root it. Turns out to be a 51 straight up. Notice that this 45 is opposite of that theta angle, while the 24 is adjacent to that theta angle. That 24 is being part of that angle, while the opposite is completely opposite of it. It's not touching that angle at all. That's how we're knowing the adjacent and opposite, even when it looks kind of weird like this. So, I'm going to go revert back to not x and y, but opposite and hypotenuse and all that kind of stuff. You can use either one, whatever's best for you. In this case, I think this is best. So opposite's the 45, hypotenuse is the 51. Cosine is, again, adjacent over hypotenuse. And so then I got this 24 over the 51. And lastly, tangent, opposite over adjacent. Again, I'm just using these formulas because they're more convenient. Same thing, though. So my opposite is the 45, and my adjacent is the 24. Okay, awesome. If you're wanting the other three, of course, they're going to want those, so that's why we're talking about them. You just flip them. 51 over 45. 51 over 24, and then finally 24 over 45. Not hard. I don't know if that's simplified or not. It wouldn't really matter. 62008. So they got another triangle. Again, they're trying to make it look weird. Here's my theta. I have an 8 right here. I got a 7 right there. And they say go. Well, notice that this is going to be opposite because it's opposite of it. This is the hypotenuse because it's the longest side. I'm wanting to find my adjacent, so I have to go and do the Pythagorean theorem, Pythagorean first. If you think of it kind of like x and y and r, it's the same formula. So what I'm going to be doing to find that adjacent side is I'm going to be saying square root of the hypotenuse squared minus the opposite squared. Just rewriting it using, instead of x, y, and r, I'm using adjacent, hypotenuse, and opposite. Doesn't really change the math. 8 squared minus the 7 squared. You actually get square root of 15, which doesn't reduce, but even if it did reduce or not, it wouldn't matter. So that's my adjacent over here now. Okay. And so, again, for this problem, I'm going to revert back to opposite over the hypotenuse and all that kind of stuff. So I got 7 over 8. Cosine is adjacent over hypotenuse. And so then I've got the square root 15 over 8. Tangent theta is going to be the opposite over adjacent. And so then that's going to be the 7 over the square root of 15. You do not need to rationalize the denominators. Just leave it alone. It's fine. And of course, to find the last 3, what do? You flip them upside down and, well, there you go. Not hard at this point, which is good. 62013. They say in this problem to use a calculator, okay? But this is just a scientific kind of calculator, is perfectly fine. Secant of 16 degrees is equal to what? Now, just hold on for a second. I don't have a secant button. I don't have a secant button on my calculator, so what should I be doing here? Well, honestly, I would just rewrite it the sines and cosines every time anyways. So it's 1 over cosine. This is something you could put in your calculator. So let me go and type that in. So 1 divided by cosine of 16. And I get negative 1.044. Why is that wrong? It's actually 1.04029. Now, I know they look similar. That's not the point here. It's degree mode and radian mode. Sorry about that. So, there we go. Make sure that this is in degree mode in your calculator because you're using degrees. That would make sense. So again, if you're getting it wrong, and like, I keep getting it wrong and I don't know what's going on with my calculator, change your mode. Tangent 51, this is straight up, just put it in. Make sure it's degree mode, 1.2348997. There we go. Okay, cool. 6.2.017. Again, they're trying to make it look weird with these triangles, but every time there is a right angle, so that's helpful. This is 60 degrees. I got, apparently this is x. It's going to be my opposite. 31 is my hypotenuse because it's the longest. And they're saying solve for x given what we have. You might be thinking, well, that is not enough. I don't know what I could do to be able to get this x. I don't have enough numbers. But you do. You do have enough. I'm going to ask you, out of the sine, cosine, or tangent, which of these use the opposite and the hypotenuse together? Opposite and hypotenuse. Which one of these guys? It's the sine. The sine uses that. Remember that sine is opposite over hypotenuse, right? So I'm going to use the sine in order to solve this problem. So sine of theta, theta is 60 degrees, so we can plug that in. My opposite is x. Again, opposite of that angle. See that? And then my hypotenuse is a 31. So to solve for x, I'm going to move that 31 over. 31 sine of 60. And I would definitely use a calculator. Remember degree mode, which we should already be in. Actually, you know what? You can use your unit circle to get this cool, nifty, exact answer. Just saying. Either way, so unit circle, calculator, whatever you got to do. If they say exact, then definitely use a unit circle. Or if you have it memorized by now, like I was hoping you would. 6.2.026. So they say that tangent, write that a little bit better, tangent of theta is equal to square root of 15. That doesn't tell me very much. It says find the triangle that actually works. That's kind of strange. It's a multiple choice. They give you 4 different options. I believe it's 4 options for the triangle, and you're just going to pick one. So what I'm going to do is I'm going to actually find my theta. To do this, I'm going to use the arctangent. We've done this back in chapter 5. So the arctan, so like I'm just basically moving that tangent to the other side with an arctan. Arctan of the square root of 15. And mine's in degree mode, which kind of helps. 75.52 degrees. Now, this is not something you're wanting, but it's going to help me in my choice, my selection. The answer looks basically like this guy here, or something like that. I think mine's actually just 75 degrees. But this is the guy that we're looking for. A 4, a square root 15, and a 1. Okay, so like that's your answer that they're looking for. In order to find all those other numbers, what I would say is, I think the 4 is included. Yeah, I'm not exactly sure what they're doing there, but, you know, whatever. It looks like that. Okay, what I do have is I use Pythagorean theorem a little bit. It seems that I plugged in a 1. So, like, they gave me the 1, and I needed to find the 4, and I have the square root of 15. So how would I find the 4? So I'd say 1 squared plus the square root of 15 squared. So that's 15 plus 1 is 16, and then I'm going to square root it, and I got a 4. I can't remember everything about it, but, well, there you go. That's what I have on my paper. After that, they're wanting to sine, cosine, and theta, and tangent, sorry. Sine, cosine, and tangent. Of theta. Now again, we already know it's about 75 degrees. That's fine, but I want to know, not with calculator, the exact answers. Notice that I have my adjacent, or you guess you could say it's x. I have my opposite, or again that's a y, and I have my r or my hypotenuse. Okay, either way. Well, I mean, you can easily go back to the y over r. It's so much easier, right? Anyways. Square root of 15 over to 4. Notice that you can just go back and forth with these formulas. You don't always have to use adjacent, hypotenuse, and opposite, and all that stuff. Use what makes sense for the problem, and just roll with that. Y over x, square root of 15 over the 1. And then to find the other 3, you can flip them. I'm not going to do that. It just takes too long. 62029. I got sine of pi over 4 plus cosine of pi over 4 is equal to what? Well, this is unit circle stuff. I'm not going to pull up the unit circle. I don't have it here. But basically, I've got square root 2 over 2. That's the y value at 45 degrees. And I got square root 2 over 2. That's the x value at 45 degrees. When I add these guys up, I've got 2 of them. I got 2 of the square root 2 over 2's. These guys cancel, and I got a square root 2 in the end. There you go. Super easy. And now pause. The rest of the problems that I'm going to be doing are not easy. Okay, so this guy, the one after it, one after that, one after that. I've got 4 problems. They're basically word problems. And they're not easy. So, you know, I'm sure that y'all can get through all that stuff that we just did pretty easily, all that stuff above. But I really want to focus on these problems because, I mean, if they're difficult, if I've seen them before, if they're important somehow, we got to do them, and we got to know how to do them. Okay. I'm saying, like, this could be on a quiz. This could be on an exam. I'm not really sure. I haven't looked, but I'm saying that these are important problems. Okay, now that you're ready, here we go. Of course, on important problems, I probably ought to draw it pretty good. So, I got these two triangles. One triangle, two triangles, whatever you want to call it. This is 60 degrees here. This is 110 right there. This is 30 degrees over here. And this right here is x. And I need to solve for x. What? Exactly. It's like, okay, that looks nice. How am I supposed to do this? What I did immediately is I broke this up into, let's say, y and z. You can use any letters you want, a and b, whatever. Y and z. Pretty easy there. I'm going to start using sine, cosine, tangent, whatever I need to use in order to find to find y and z, and then I'm just going to put those together to find my x, okay? So let's focus on this side for a second, okay? So I'm looking for my y. I'm looking around. There's a y right there. And I'm just looking at that triangle only. Okay, so this is 60. This is a y. This is a 110. Notice again, opposite, adjacent, if you want to go that way, whatever. Well, what out of the sine, cosine, and tangent, which one uses opposite and adjacent together? Which one uses an x and a y value? It's going to be tangent, and so my tangent of 60 is opposite over adjacent. And I can solve for y. So I'm going to move this around. Y is equal to 110 divided by the tangent, 60. And then calculator, I got 60. Again, this is degree mode. Make sure you're still in degree mode here, okay? Thankfully, we're using a lot of degrees, which is kind of easy on our minds. We don't have to keep converting back to radians and stuff. So there we go. We got our y. So that little distance right there is apparently 63. Okay, well, what about the other triangle? What about this guy right here? See how I'm breaking it down into two different ones? So that's 30 degrees. This is z, and this is 110. Again, notice that I'm using an opposite and adjacent. Same as last time, tangent, now of 30, is equal to opposite over adjacent. Move these around. Z is equal to 110 over the tangent 30. Definitely use a calculator here. And definitely still in degree mode. 190.525588. So these guys are actually important because, again, we got that long distance now. We got the shorter distance now. I'm going to add those two together and get my x. Because x is equal to y plus z. When you add them together, 63.5 plus the 190.5. Again, I'm rounding there, but I won't round in the real answer. 254.03408. Awesome. There you go. We did it. 3 more to go. 62053. So I have a triangle here, and there's like someone standing over there or crawling or something. I don't know. 1 mile away. It's 1 mile. The angle. What? Oh, that's 11. 11 degrees. On my paper, it looked like 110. 11 degrees. And then this is some height of a building or something like that. It's like a building. So what's the height of the building that he's looking at there? So he's on the ground. He's looking up at this top of the building, and it's an angle of 11 degrees from the ground, and he's 1 mile away. I'm thinking it's a pretty tall building, but we'll see. Notice that my triangle has an opposite and an adjacent. Okay, so what uses opposite and adjacent? Again, it's tangent. Tangent of 11 degrees is opposite over adjacent. That's 1 mile. Well, you don't need to divide by 1, so just go and find this in the calculator, I suppose. So h is equal to 0.1943, and that's miles. But that's not what WebAssign wants. Apparently they want feet. So how do I convert over to feet? So 1943 miles. Well, I know that there's 5280 feet in each 1 mile. And notice that my miles are going to cancel out, leaving feet. So I multiply those, and I got the 1026.32 feet. Just like that. Okay. Again, didn't we talk about this in a previous section? Note that somewhere on a note card or write it down somewhere, remember it, the feet in a mile. They're just going to use it randomly throughout the rest of the class, apparently, so just make sure to have that around. Okay, so that's a pretty tall building for me. 62057. So we got another building, and there's this ladder. Leaning on the building, okay? The ladder is 19 feet long, and the angle that it's making with the building right now is 63 degrees. Again, I'm very happy all this stuff is in degrees. They want to know what's the height right here. What's the height? So I'm thinking, well, this time I have a hypotenuse, and I have my opposite. What uses hypotenuse and opposite together? Well, it's actually sine. Sine of 63 degrees is opposite over hypotenuse. And so then I'm going to multiply by 19. H is equal to 19 sine of 63 degrees. And just put it in the calculator. Make sure you're still in degree mode. 16.9291, and that's now in feet. Okay. Okay, next problem. 62057. Okay. Oh, no, actually, we just did that one. Sorry. I paused the video, and it all changes. Okay. Last problem. Here we go. This one's actually very difficult. 620. I think it's 60. It could be an 8, but I think that's a 6. You know, my handwriting's not the best. So there's this hill, and then it kind of goes down some, and there's a flagpole. I'm trying my hardest to make a flagpole here. Wow, that is a crooked flagpole. There we go. And, well, there's a flag on it. So there you go. Standing on the hill, this person's looking up at the top of the flagpole and the bottom of the flagpole, okay? And from a straight, flat line, we have 14 degrees, and here we got 18 degrees. Now, of course, it's not the scale, but you get the idea. They know, or the person knows, that this is 55 feet tall for the flagpole. What they're wanting to know is how far away that person is from the flagpole. Solve for x. So, what's the distance in order for all that stuff to make sense? Well, I'm going to have to break this down into smaller triangles, just like we did on other problems. So I'm looking at this guy, okay, 18 degrees. And then I've got another one, 14 degrees. Notice that I know this is 55 total, but I don't know what the individuals are. So, like, what's this distance here? What's this distance here? And I'm going to go ahead and label them as Y and Z, just so that, again, same as that other problem, I got to use some kind of letter. So up top, this would be a Z. Down low, there's a Y. And this is still an X, and this is still an X. Okay? Because X, again, if you're noticing, X is this distance right here. You see that? Same distance. That's X. 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 Okay. Both of these problems are using opposites and adjacents. Opposite and adjacent, I would use tangent. So tangent 18 degrees is equal to opposite is z, adjacent is x. Tangent of the 14 degrees. Opposite is a y, adjacent is the x. Okay. I know you're thinking, well, why is a negative here? No, just don't worry about that. It's opposite. It's going to be okay. So I want to solve for x or something like that. And rather, what if I solve for y and z in terms of x? In a way, I'm going to just move my x's over. And so I've got z is equal to x, tangent 18, and y is equal to x, tangent 14. Okay. I know that y plus z is equal to that 55 feet originally. Remember, 55 feet? If I add these together, I should get the 55. And so that's what I'm going to have now. X tangent 14 plus x tangent 18 is equal to 55. Solve for x. It's actually not too hard. What I'm going to do is factor the x's out to the front, leaving this guy here. Then divide by the 55. This is one big number. I don't know what that number is, but I'm going to divide it. And I'm not finding the decimals ahead of time because I want to show you something, okay? I want to show you something. So this is all in the denominator. Make sure that you're using parentheses around your denominator whenever you're, doing your calculator and all that kind of stuff. Okay? But there you go. That's actually your exact answer. They don't want that. They're going to want the decimal. Blah, blah, blah. Put it all in the calculator. I got 95.77748. Again, that's feet. That's your final answer. But look at this guy for a second. I don't want to say the word. It's very interesting, the numbers used. 55, 14, and 18. 55, 14, and 18. It's the three numbers they gave us at the very beginning. Perhaps this is some kind of a formula. Ooh, I just said it. Okay. All right, we're done. Thank you very much. Have a great day.